By normalizing your relations, you segregate logically related pieces of information into multiple tables. To maintain consistent data, the database has to enforce the referential integrity of these logical relationships between tables. For example, if student data resides in one table and enrollment information resides in another table, the database has to be able to ensure that every student ID in the enrollment table has a corresponding record in the student table. You define a relationship between two relations by creating an attribute or set of attributes, which is called a foreign key, in one relation, which contains values that match the values in the primary key of the other relation. For example, each row in the enrollment table has a foreign key column student ID, which contains a value that also exists in the primary key student ID column in the student table. You can allow foreign key columns to contain null values, but any non-null values have to match primary key values in the related table. And SQL Server can enforce several kinds of relationships, including one-to-many, many-to-many, and one-to-one. A one-to-many relationship is based on matching the values in the primary key of one relation with the values in the corresponding foreign key of another relation. Each tuple in the first relation could potentially match many tuples in the second relation. For example, one student could be enrolled in many classes. The student enrollment relationship is a master-child or has-a type of one-to-many relationship. One student has some number of class enrollments. A student might exist who has 0 class enrollments, or 1 or more, but every student enrollment maps back to exactly one student, and that's what's shown here in this figure. This type of relationship sometimes also represents containment. For example, an order contains many order details. In the case of the student enrollment, the student ID is the primary key of enrollment, but it doesn't comprise the entire primary key in that table. Class ID is also a foreign key in that table, and that makes up the other part of the primary key. Another type of one-to-many relationship is a lookup or is-a relationship. For example, each instructor is a member of a department in the school. The record in the department table with a value of domestic arts matches any number of records in the instructor table because that department has multiple instructors teaching its courses. But each instructor matches up with exactly one department. Each student can enroll in many classes, and many students can attend each class. This is called a many-to-many relationship, and you can represent it in the database only by using a third table. The enrollment table records the various pairings of students and classes. The primary key in the enrollment table is a composite key that contains unique combinations of student ID and class ID values. The word many, as used in database theory, is a bit of a misnomer. This applies both to one-to-many and many-to-many relationships. It really means 0 or more up to infinity. So multiple might be a better term to use. But many is the term widely used, so I'm going to stick with it here. In addition, consider that each course may be taught at different times during the week, taught by different instructors, and taught in different rooms. So the class table represents several many-to-many relationships between courses, instructors, and rooms. And those are all shown within this figure.